Assalamu alaikum everyone. Welcome to Algebra, lecture number 17. We are focusing on the sketches. Last time we talked about quadratics, we talked about the general form, the completed square form, the factorized form, and this is just a glimpse of what we did last time. Something about symmetry, symmetry about the turning point, line symmetry, the conversion from the regular form, the general form to the completed square form, and vice versa. So now if I look at this page, we were talking about graphs of functions and draw and interpret graphs representing exponential growth and decay problem. I'll focus on that. I'll focus on this last part, that is the exponential and the reciprocal, in which there is transformation of functions. Knowledge of turning points, vertical, horizontal, asymptote, roots, and symmetry is required. So last time we talked about quadratics. This time we are talking about the power function, also known as exponential function, because the word is exponent. That means index or indices. So that is what we are focusing on. So y is equals to a power x, a is greater than 0. If I draw this graph, let me just draw a thin line over here. That is the x-axis, that is the y-axis, and the graph, it goes like this. So not like this, this is like this. So that's the graph of the power function. So we know that when x is 0, y is a raised to power of 0, which comes out to be 1. So the y-intercept is 1. The graph gets very close to the x-axis, but it does not touch it. It gets very close to the x-axis. So this is, let me just shift it to the side, something like this. And over here, it gets very close to the x-axis. The equation of x-axis is y is equals to 0. Now this line over here, this line is an asymptote. What is an asymptote? That is, the graph gets very close to the line but does not touch this line, does not cross this line. So what is an asymptote? The graph gets very close to this line but does not cut or touch it. So these are the two main salient features of this graph. First of all, what is the salient feature? The y-intercept, that is x is 0, y comes out to be 1. That's the one thing. The second thing is what? The second thing is the asymptote, that is the x-axis. And what's the equation of the x-axis? Y is equals to 0. Now let me plug in some values, which was plugged in last time also when we were discussing the sketch. So now it's the time to delve more deeper into it. When x and y, and let me plug in y is equals to 2 power x. This a over here, this base over here, that base has to be positive. And the base should not equal to 1, because 1 is a useless number as a base. So I have chosen x, the base as 2. Let me plug in -3, -2, -1, 0, 1, 2, and 3. So now 2 raised to power of 0 is 1. 2 raised to power of 1 is 2. 2 raised to power of 2 is 4. 2 raised to power of 3 is 8. What about 2 raised to power of -1? That is half. 2 raised to power of -2, that is 1/4. 2 raised to power of -3, that's 1/8. What do we observe? We observe that these y values, or this value, or this value, they can be positive. That is acceptable. The y values, that is positive. But y value does not equal to 0. Y value cannot be negative. So that is not possible. These two, that's not possible. So that is why we have the asymptote, the x-axis, which is y is equals to 0. So the graph does not, the y values remains positive. It becomes very, very small or very, very large. And by the way, this is a graph of growth. because it shows exponential growth. So let me write over here, this graph shows exponential growth. And this is the concept of doubling. 1 over 8 multiplied by 2, 1/4, 1/4 multiplied by 2, half, half multiplied by 2, 1, 1 multiplied by 2, 2 multiplied by 2, 4 multiplied by 2. So this is the concept of doubling, because y is equals to 2 raised to power of x. So that is an exponential graph. So now what I can do over here is that let me get started with this idea of drawing the graph of y is equals to 2 raised to power of x plus 1. Now these are the y values. What will happen? Each y value will be increased by 1. So this becomes 1, 1 over 8, this is 1, 1, 4, this is 1.5, this 1 will become 2, this 2 will become 3, 4 will become 5, 8 will become 9. So the y value will be increased by 1. That means the y-intercept will be changed. Let me draw this line. That is y is equals to 1. So this is the line, y is equals to 1. And this graph, the curvature, let me just grab this curvature from here, and I've copied it. And let me paste it over here. So this graph goes like this. And now this y-intercept is 2. This is 1, this is y is equals to 1. So two things are happening. The asymptote, the new asymptote is y is equals to 1. It was initially y is equals to 0, now it's y is equals to 1. And what's the other thing? The new y-intercept, that is y is equals to 2. So now it's 2 at 1 and 2. Before that, it was 0 and 1. So both things have been increased by 1 unit. So that's how we have drawn the graph of y is equals to 2 power x plus 1. And this can apply to anything power x as long as that anything, the base, does not equal to 1, because 1 is a useless number as a base. Let me now draw the graph. Let me again choose this thing. And let me draw the graph of y is equals to 2 raised to power of x minus 1. So now let me draw this thing, which is over here. So I'm drawing this graph. This is y is equals to -1. This is the y-axis. This is the x-axis, the new asymptote. So the new asymptote is y is equals to -1. First it was y is equals to 0, now it's y is equals to -1. And the new y-intercept would be y is equals to 0. So let me just plug that graph over here. That graph goes like this. It is touching this point, which is 0. This is -1. Now just have another look. This is 0 and then 1. This is 1 and 2 because it was risen up by 1 unit. Now it has gone down by 1 unit. So the y-intercept 1 now became a 0. The y is equals to 0 now became y is equals to -1. It's still a graph of growth. Now, that means if I talk about exponential growth, so when we talk about exponential growth, so we are talking about y is equals to a power x. A has to be positive. A should not equal to 1. And it could be y is equals to 2 power x. That is the concept of doubling. It could be y is equals to 3 power x. That's the concept of tripling. And what if I have y is equals to half power x? What do you think this will happen? What do you think will happen? This is 1 over 2 raised to power of x, which can be written as 2 raised to power of -x. So basically, this is the concept of halving, half it out. So this halving, this is basically the concept of decay, because 2 raised to power of negative x, when the power is negative, this is no more growth, this is decay. So now let me draw the graph of this decay. So let me write over here, let me draw up a table first of all, and let me write over here x, and then y, and then -3, -2, -1, 0, 1, 2, and 3. Y is equals to 2 raised to power of negative x, which can be written as 1 over 2 raised to power of x, which can be written as half raised to power of x, because 1 raised to any power will remain as 1. So now if I plug in this value, if I plug in -3, 2 raised to power of negative 3 is 2 raised to power of 3, that's 8. This comes out to be 4, this comes out to be 2, this comes out to be 1, this comes out to be a half, this is 1 over 4, this is 1 over 8. Again, the rule is the same, that the y values, these y values over here, these y values, they can be positive, they can be integers, they can be fractions, they can be greater than 1, they can lie between, it lies between 0 and 1, but it can never be 0, it can never be negative. So that's not possible. So again, if I draw this graph, so over here, like this, and let me draw the purple graph over here, that's right over here. Okay, so the graph goes like this. Let me make it more better. Okay, so now this is the graph of y is equals to a raised to power of negative x. A is positive, a does not equal to 1. Again, 2 raised to power of 0 is 1. This is x-axis, this is y-axis, this is a graph of exponential decay. And the value of x increases, the value of y decreases. 8 into half is 4, 4 into half is 2, into half is 1, into half is half, 1/4, 1 over 8, and so on. So this is a graph of decay. And again, let me just erase this thing over here. Okay, so now over here, this is the x-axis. That's the asymptote, y is equals to 0. So y-intercept, y is equals to 1, asymptote, and it's a horizontal asymptote. So there could be a vertical asymptote, this is a horizontal asymptote, this is y is equals to 0, and these are the two salient features of this graph. So let me do a bit of transformation of this graph. So for example, let me draw this thing. Let me just copy this thing. Okay, and let me just copy this thing over here. Okay, now let me just change the color so it doesn't mix it up. Color, let me choose blue, no. Okay. Now, if I plug the graph like this, that's how the graph moves. It can move up, it can move down. Now, let me draw the graph of y is equals to 2 raised to power of negative x plus 1. So what I'll do is that I'll draw the graph y is equals to 1. That goes like this. And over here, this is y is equals to 1. And then let me paste the graph like this. So now the new asymptote, it's not drawn to scale. It's a little bit awkward. Hold for a second. It's too slanted. So let me just draw with respect to this. So over here, this purple graph. Something like this. Okay, I think that is good enough. So this is 0, 2. This is the new asymptote. So the new asymptote is 0, 2. And the new intercept, asymptote is different. The new y-intercept is 0, 2. And the new asymptote is the line y is equals to 1. It's all because of this 1. The asymptote has risen up by 1. The y-intercept has risen up by 1. That's the basic idea. Similarly, if I draw the line, y is equals to 3 raised to power of negative x minus 1. Again, it doesn't make a difference what the base is as long as it's a positive number. 3 raised to power of negative x and minus 1. So now let me draw the line that is negative 1. And this is y is equals to negative 1. This is negative 1. Let me mark over here. This was 1. And 3 raised to power of negative x. This is decay. So let me just draw a green graph over here like this. Okay. So now 3 power x minus 1. Hold for a second. No, not exact. Okay, I think that would do the job. Okay, so now this is 0. It's passing through 0. The new y-intercept, is y is equals to 0. The new asymptote is y is equals to 1. Again, this is a graph of decay. That's how it goes. Okay, so it's not going to turn up like this. So let me just take this, something like this. Let me just erase this thing. I think that is better. And this is y is equals to negative 1. This is the y-axis. This is the x-axis. That's the x-axis. That's the y-axis. And also we here x and y. And over here x and y, this is y, this is x, and that's how this thing is drawn. So let's stop over here, and this is lecture number 17, and let me also adjust over here. So that is 17 over here, and that is lecture number 17. That's the concept of exponential graph. Transformation that we did is this thing, y is equals to a power x plus minus a k, or y is equals to a power negative x plus minus a constant. This is a graph of growth. This is a graph of decay. And if there is a plus k, it moves up. If there is a negative k, it moves down. That is the transformation that we have done. So till the next class, take care.